Greeting, wolves. Today we're going to be talking about dissolved oxygen. What is it? Where does it come from? Why do we bother measuring it? Because you are going to be measuring it in the next class session. So I want you to think of it kind of like a health checkup. When you go to the doctor or the nurse listens to your lungs, they listen to your heart. They may, especially as you get older, they may be doing blood and urine tests on you to see how healthy you are. That's a health checkup, and we're doing a health checkup on the stream. So this is a form that you'll be filling out. Don't bother looking at it a lot right now, but you're going to be measuring water temperature, pH, conductivity, things that don't mean much to you now, and dissolved oxygen. So, what is dissolved oxygen? Well, first of all, we have to know that our breathing, we breathe in to get oxygen, and we blow out carbon dioxide. So, what is that? Well, carbon dioxide is carbon a carbon molecule with two oxygen molecules attached. So, that is what oxygen is, and oxygen comes out of a plant. When the plant is photosynthesizing, the oxygen goes out into the air. We animals breathe in oxygen. Plants take in some oxygen too, and then you and I and all other animals put out carbon dioxide. That's the carbon with those two oxygen. The plant metabolizes that with the energy from the sun and then releases oxygen. So that's the oxygen cycle. Now, where does all your energy come from? And I don't mean just your energy, all animals. You remember our little hackberry psyllid that we had last week? Well, it needs energy too. It needs energy to grow, to move and run. It didn't run very fast, but we watched it move, and to reproduce, to have its babies. So all of that energy, where does that energy come from? Well, it comes from food. And where does food get its energy? Well, it gets its energy through photosynthesis. So the sunlight comes in, it hits the plant. The plant uses chlorophyll, and it metabolizes it to grow. So the leaves grow, the stem grows, especially the roots grow. The roots absorb water, and the plant takes in oxygen and puts out carbon dioxide. So now that's true of not just the plants, but algae and other things like fungi. So that is how that oxygen comes about. Now, there's a food web, and that is the producer over here on the left. That's a plant, any plant. So it can be the hackberry leaf that we saw. It can be lettuce or tomatoes that you're eating. But all of those things are the source of that primary energy. Then it's eaten by a consumer. Now, you and I are consumers when we eat our salad, but let's go back to this hackberry or to a butterfly larva, a caterpillar munching on a leaf. It's the primary consumer. It's consuming the energy that is produced by the plant. A secondary consumer may go along. This frog here that eats that caterpillar. And maybe a snake eats the frog. And maybe an owl comes along and eats the snake. Eventually, all those things that die, including your poop, go into the soil, and decomposers, such as mushrooms, break down, fungi, break down that product, goes back into soil, enriches the soil, and the plant grows with that enriched soil. So, where do we get our energy? Well, it's all from the sun. Energy from cars, houses, humans. We don't think about it all the time. You can see that hamburger there. We know where that came from. That came from a cow. And the cow consumed grass. But the energy that we have, such as the how should I say it? The gas, oil, the natural gas, plugging your computer into the wall for electricity, all of that comes from the sun because that material has been stored up in the earth for years and for millions of years, and that comes out as coal and oil, and then we use those energies to create, for instance, electricity. So, going back to where we started, dissolved oxygen. We're going to be measuring dissolved oxygen. The question is, how do fish breathe? Do they inhale and exhale like you and I do? Well, let's look at that. How do you breathe, for instance? Well, you have lungs, and your lungs draw in air and blow out air. And so think about it right now. Take a deep breath. Okay, now blow it out. Okay, let's see what we were doing. When we inhaled, we brought in oxygen. It brought it into our lungs, and our lungs get it into the bloodstream, and it goes throughout our body. That's inhalation. Diaphragm moves down, we inhale. I'm breathing out, the diaphragm comes up again, carbon dioxide goes out and into the air. So that's how you and I breathe. Now, in the fish, the oxygen is dissolved in the water. And we're going to talk in a minute about how it gets there, but both through photosynthesis and from the air above the water gets dissolves some oxygen in it. Now, how does a fish breathe? Right, it breathes with gills. So those gills, the water comes in through the mouth, it goes through the gills, and the water goes out. It absorbs oxygen through those gills, and there's blood that goes through those gills that picks up that oxygen and carries it to the body of the fish. So all of that oxygen coming around from the plant, sunlight, and releasing oxygen in the air, we breathe it in, it comes back, carbon dioxide. That's the oxygen cycle. Now, we're talking about dissolved oxygen in the water. Well, let's look at that. Oxygen can come into the water through the surface of the water. It can come from plants that are producing oxygen in the water, and it is then in there until it's consumed. Bacteria, animals, we absorb the water from that. It's a whole cycle there. So the fish need the oxygen in the water. So how much oxygen is there, and what changes the oxygen? Well, let's look at that. The things that increase the dissolved oxygen level, we talked about plants. Cooler water holds more oxygen. So if we have, for instance, trees growing over our creek, that keeps the water cooler and we have more oxygen. Turbulence does. If you think about, if you took a bottle of water and it's got some air at the top, and if you shake that bottle, wouldn't you think that you'd get more oxygen in the water? And that same thing happens in streams. So a moving stream going over ripples causes that oxygen to be picked up. So streams and rapids. Now, what knocks it down? Well, animals consume the oxygen. Fish, frogs, other things that underwater, decomposing, rotting plants and animals and animal waste like poop, all reduces the amount of oxygen in the water. We said warm water already, and then sewage or bad things that we add have that effect. Now, how does that affect the food cycle? Well, we know that there are several things, and you're going to be measuring this a little bit later. We can look at the things that are in the stream and measure them. We're going to be collecting these samples, and you're going to find things like stoneflies over here on the left, stoneflies and caddisflies, they're very sensitive to oxygen. If there's no oxygen, they're not going to live there. We have some others that can take low levels of oxygen, like damselflies and dragonflies. So they're somewhat sensitive to it. And then we have some species that they don't really worry about it, even if the oxygen levels are very low. And so by measuring those and seeing the relative number, if we have a whole bunch of tolerant, group 3 over here, and none of the sensitive, that tells us that there's a lot of pollution in the water. If we have, like down on Bull Creek where you're going to be going with us, if you have lots of stoneflies and caddisflies, that tells you, boy, this is really good water. So what can affect that water? Well, we've got animals. If you've got animal waste going into the water, that's going to reduce the oxygen. It's going to make it so that fish can't even live in it because there's not enough oxygen. If we have a lot of algae in still water and it turns green like this, there's very, very low oxygen levels. So we don't want that to happen to run into our streams or your pond. And then there's sewers. So the sewage coming out of the sewer here is going to be polluted. It's got poop, it's got urine, it's got decaying material, and all of that reduces the oxygen. And if that sewer drains into a river, like the James River, later on we'll be talking about that and how do we clean up what comes out of a sewer. But when it gets into the water, that decreases the oxygen levels and everything else that lives in the stream. What we want is something like this. This is at Bull Creek. This is our land. This is our swimming hole. And it's our little buddy that's enjoying it. And you can see how clear that water is. You can see all the way to the bottom. So that's good water. And that's what we're measuring when we're measuring stream health and dissolved oxygen. We're doing a physical exam, just like you have at the doctor. We're doing an exam on the water to tell us that the water is good. So with that, you'll have this that you can play at home, kind of refresh yourself. It's what we did in class. And I hope it'll make you ask more questions. And that's all. Goodbye.